Okay, perfect. So yeah, then thanks a lot for having me today. I'm very happy to be here. As you can see, my name is Tobias Fenster, as also already introduced. On my day-to-day work, I'm a managing director and co-founder of a company called 4PS. Actually, there's also a 4PS UK. We create an ERP for construction companies. So on the very low chance that someone of you is working for a construction company, that might also be interesting. And then on the community side, I'm in the Microsoft community and the Docker community, and that brings the two topics together of containerization in .NET. So this is why I got into that topic. I have a little blog and a podcast if you want to follow that, and also feel free to find me on LinkedIn or on Blue Sky. Always happy to have a discussion, to have a talk on everything tech, but mostly, of course, the things I know a bit more about. In between, if you have any questions, feel free to put them in the chat, and maybe you can interrupt me. No problem at all. It's just my brain is not able to compute both having a talk and watching the chat, so I won't be able to do that. But let me know if there are any questions that come up. So to jump into our topic, container-based development for .NET or C# developers, what we're going to tackle today is two parts of it. And that's first during development. So how can you use a container during development? And then during runtime, when your app is done or when you want to deploy it into a test environment or production, how do you need to prepare for that? How do you create that container image that you need to run a container? So those will be the topics for today. But let's start with development in a container. The question, of course, is why would you? And I think that's always a good question to start with. To give you an idea, if you look at where we currently are, where a lot is serverless, a lot is managed, everyone tries to stay away from infrastructure, basically. You try to just develop your code, and then the rest is automated, infrastructure as code, whatever. And then you look into the development tools, then they are typically still installed manually, right? So at least for companies that I worked for that I've seen, it used to be some Word document or wiki article that someone has created maybe 2 years ago, and then you get into a project or you're new to the company, you get that document, and you can try to run away with it, but it's oftentimes difficult. So the idea for container-based development basically is that you have development environments that are clearly separated. So the advantage from a resource utilization point of view is that you don't need the overhead of maybe a VM, but also because they are cleanly separated in a container you develop in one container per project, you also don't have version conflicts and side effects. .NET, of course, is quite good with having different versions, but maybe you also work with different tech stacks where it's not as easy, or you need different kind of tools, different kind of SDKs, whatever additional things you might need. And then it can become more complicated. So then it's also nice to have things in a container, separated from each other, separated from your host. So that also means that after time, when maybe things don't work perfectly anymore, you can just throw the container away, create a new one, and you're ready to go. The configuration file of that dev container also lives next to your code in the repository. We will see that in a second. That means that everything that you need for development, like the dependencies, the tools, etc., are all described in that configuration file. So we have kind of like an infrastructure as code approach for local development environments. It also means that the different developers are no longer drifting apart. So one is installing a bug fix, the other is installing a minor release of an SDK or whatever, that kind of thing that happens over time. But if you put this in the configuration file, then it's always clear we're working on this version, we're working with that particular tool, we're working with this SDK, and then it just works. And it also means that when you're changing versions, it's the same as making a change in your source code. You basically commit it, you push it into your repository, someone else pulls at a specific point of time, and then you get a little notification. Your dev container configuration has changed. So someone else made a decision to add another tool, or you move up a version or whatever, and then you can just recreate your container and everything is on the same version. That also means that you're extremely fast to set up development environments, as we will see in a second. So onboarding new developers is quite easy, but also to switch between projects with different tech stacks, different environments, that also works quite easily. How can we do that? The implementation that I will show you today is with Visual Studio Code development containers, but there are other implementations. There actually is an open standard for dev containers, and other IDEs have also implemented it. I work a lot with VS Code. I'd like the implementation there, so that's why I'm showing you that, but it's not the only option. What we get is a containerized, configurable local development environment. We connect via Visual Studio Code, and we have basically the same functionality that we would have if we would develop without a development container. So we can use extensions, we can access local resources. We have offline support, basically everything that you would have without a dev container. All of that works. So that means that we have a very good environment for almost all scenarios. The only exception is, funny enough, Windows-based development, because dev containers don't work in Windows-based containers. As you maybe know, you can easily run Linux containers on Windows hosts. So what I will show you today is a Windows VM where we will run dev containers. So if your laptop, your dev VM, whatever is Windows-based, that doesn't matter. But if you really have to do development directly in Windows for whatever dependency, then that won't work in containers. It's also, but that's more of a side note, a great starting point for GitHub Codespaces, because they basically have the same technology behind it. That means that if you are getting set up with dev containers like we do today, it's a very easy step up to then use GitHub Codespaces as well. And then the last slide before we dive into the demos, just to give you an idea how things work. Let me grab a pen here. So we basically have on the local machine, so in my case, in the demo that I will show you, a VM, but could also be a local laptop, where we have Visual Studio Code, basically the client side of it. And everything that is UI related, a theme, something like this, is also running in that in the client side here. But then we also have the container running, and that container contains the server component of Visual Studio Code. It comes, of course, with its own file system, and it runs, for example, a terminal. It can run your application, it runs the debugger, and it runs all of the workspace extensions, the code completion, etc., those things that run in your Visual Studio Code. And the source code you could directly put in the container, as you see here, but the typical idea is to have it via a volume mount. And the reason for that is that if you have it directly in the container and for whatever reason you throw away the container, then your source code is also gone. Of course, it should be in your Git repo anyways, or whatever you use for version control. But still, by using a volume mount, that means that the source code actually also lives on your host machine. So if you accidentally remove the container, then your source code is still there. Okay, that's the theory. I hope you got an idea why it might make sense to use this and how it roughly works. But I think the most interesting part of it is how it actually works. So let's take a look at it. Yeah, now you should see Visual Studio Code. And what I will do is the scenario when someone else has prepared a dev container configuration in the project. And now I'm coming in as a new developer or whatever, and I want to run that dev container. What I then can do is I can select, oh, wait, let me show you one other thing just to prove it. If I run .NET on the host machine, you can see it's not recognized. So I really don't have .NET in that scenario installed on the host, but we will only run it in the container. And even in Visual Studio Code, you can see here, I have the dev container extension installed. I have the Docker extension installed. That is actually not a requirement, and the REST client for some testing. Technically, the only requirement would be the dev containers extension that I need to run dev containers. What I wanted to show you is, let's assume I have a repository somewhere. I know that has a dev container configuration, and then I can easily just say, okay, clone the repository in a container volume. It's in this case, on GitHub. So it's in my account and it's called dev container sample. Take the main branch. And what it now does, and I'll open the log here, but that's gonna run through very quickly. It basically clones the repository, figures out that there actually is a dev container configuration file, and then starts the environment for me. And that is something I didn't want to have yet. I'll do that in a second. So now you have here more or less the standard .NET new web API. So I didn't prepare a fancy demo or a complicated one, but really this is just very, very simple and easy example code. And now you can see if I open up a bash here, we are now in the dev container. So you can see this is already Linux, because as I mentioned, dev containers are Linux based, and actually it's not running the .NET restore, which I would have hoped that it automatically does, but let's see. Okay, that manually, yeah. Okay, so now you've seen, because I'm now in the container, I can actually do the .NET commands. It wasn't installed on the host, but I have it in my container. And now the whole development experience is the same as you would expect. For example, you can see here I have set a breakpoint. Let's start debugging here. That is exactly the same as it would be without a dev container as well. I can see it starting, and I can see my breakpoint already hit. Let's continue, because it automatically opens up the dev container, and I can get to our weather forecast. Again, the breakpoint hits, and I can step through. I can see local variables. I can do, basically just the same things that I would do in any dev environment. And now I have the response here. So this is really the same experience that I would have if I would develop outside of a dev container. But the big benefit is I don't need to think about, okay, which version is it? Do I need to install the SDK? Do I need to set up anything else? Because that is stored in the dev container configuration file. So let's take a look at what that is. And that's actually a pretty easy JSON file. You can see here it has a name. It uses a container image, .NET 9 in that case. I can add additional features. For example, this here allows me to use the Docker engine on the host from within the dev container. You can also see here, after the container has been created, I'm running a command. In that example, I'm running the command to create development certificates. And you can also see that I can, for example, add extensions, so that if we agree in the team that we also always want to use the REST client or some C# development or GitHub Copilot or whatever, you can just put it in the extension list here. And then when the container starts, sorry, wrong one here, I can see here what is in the dev container, and there is the REST client already installed. The other ones are part of the default image. So all I basically need is this dev container JSON file that is part of my repository, always in the .dev container folder, and the rest in VS Code works automatically when I say clone repository in container. What I can also do, to give you an example, I could say new dev container, and here you can see all the default configurations that are in here, and that's really a pretty long list. What I use is the C#.NET dev container. If I would go through this would be a wizard that allows me to select the version and additional features, and I can do that setup in a wizard basically, and then in the end I get a configuration file like this. So setting it up from scratch actually also is quite easy. Let me see, what else did I want to show you? Maybe also, how do you add extensions? If I go into the extension list here, and say, for example, I want to work with Git lens. Then I have it here. Now I could install it. That would just put it into my dev container, but I can also do a right click and say add to dev container JSON. And then you can see here that it has just added that. So setting up a new dev container configuration actually is pretty easy. You just select the basic image. You might have some additional features. You select the extensions, you commit into your repository, and then you're ready to go. So yeah, really pretty straightforward. And as you've seen, as someone to use it with an existing dev container configuration in a repository, that is literally just a couple of clicks. I need to know where the repository lives, and the rest works automatically for me. And just to show you, if we go into Docker Desktop, I can now see here that the container is running. It's always called VSC dev container. Oh no, actually VSC dev container sample is because my repository is called dev container sample. So I also see that container like all the others. There's no hidden magic or whatever. That also just works as you would expect. Okay, this is the first idea about how you can use dev containers. So main point I want to make is it's pretty easy. So if you have half an hour to give it a try, I can only encourage you to try. By now, I'm doing basically all dev container, all development that I can in a dev container, because it's so much easier, especially for things that maybe are more side projects, or you know that you will maybe have in half a year the next contact with, then it's very, very convenient as well, because you know it still works exactly the same. Maybe you need to upgrade, but the project still will work because everything is in the container. Now let's switch gears a bit. We've now seen the development side. Now the question is, okay, I'm done with my environment. I'm done with my development. I want to move into production. And then the question is, okay, how do I put the code that we have into a container? How do we make sure we can run this in production, for example, in Kubernetes or whatever serverless environment or whatever you might need? I think by now containers really are a bit of an industry standard. So I want to share with you what are best practices to get your container production ready. So what we will do is we will use that project that we have seen in the dev container that has been created with a .NET New Web API. We will put it in a container, and then we will take a couple of steps to show you how you can optimize that container image. And we will look into vulnerabilities, how we can find them, what we can do about them. But first of all, let's put our little project into a container. And for that, we need what is called a Docker file. That is, so to speak, the recipe for creating that Docker image. The Docker image can then be instantiated into a container. So it's basically, as you will see in a second, just a step-by-step instruction of what needs to be done to get our application up and running. Because I'm very bad at typing, I have prepared this and put it in here. And now you can see in the first line, maybe zoom in a bit. In the first line, you can see here that we select the base image. So that's basically the starting point. And I say, okay, I want to do .NET development. I want to run a .NET application. So let's start with the .NET SDK. And you can see here, this is the version where I, for now, just say, okay, I want to use the latest. I also say that I want to expose port 5000 in that case. So I'm telling whoever is running the container that something will listen on port 5000. And to make sure that my application actually is doing that, I'm setting the environment variable here. Then I'm creating a folder called source. I'm copying in everything that I have locally. I do a restore. I do a publish. I switch into the folder where I have published, and then I basically just run the DLL with the .NET command. So if I save that one and go back in here and do a Docker build, let's say it's my image version 001, and use the current folder, then it will automatically, by naming convention, pick up that this is the Docker file and will create everything for me. I have now cached everything. Because I have run this before. Let's show you how it looks like without the cache. So now you can see, first of all, it's fetching the base image that has already been downloaded before. And then I can see, okay, now it's copying in the files, it's running the restore, it's running the publish, it's changing the folder, and that's it. So now I have created my image called myimage001. And I want to take a quick detour doing a Docker Scout CVC myimage001, because that will take a minute until it has finished. Oh, and I need to run an update. But this is the way how we can check our image for vulnerabilities. Our image is quite big, so this will take a bit, which is why I started it right now. But let's go back in here. First thing, of course, is check whether it actually works. So we will do a Docker run. We've seen that it runs on port 5000, and I can say that I want to map this on port 5000 on my host. I want to have it interactively. I want to delete it as soon as it is stopped. And I need to reference the image that we just created. So this is now running the application. And if I now go in here, go to port 5000, we are getting the same weather forecast, of course, but now it's coming from the container image. So what we've done now is with that Docker file, we have created a Docker image that uses our sources, does the restore, does the publish, and then when we do a Docker run, it executes that entry point that we have seen here, the .NET Project DLL, and is running the application. So that is the very simplest form that we can do to create such an image. To show you the size, we now have an image that is 845 megabytes for an application that does basically nothing. That's quite impressive, and we will definitely work on getting that a bit smaller. But that's our starting point. Let's see where we are here. Okay, that one is still analyzing. So let's take the next step, and then afterwards we will get back to the vulnerabilities here. So first task is basically done. We have something in the container. Now let's look at how we can optimize it. And the first step for optimization is that we think about the base image. For building everything, we can use the .NET SDK, which contains the .NET CLI, the .NET Runtime, and the ASP.NET Core Runtime. But we should never use latest. Oh, actually, that slide is outdated. By now, it's actually 9.0, but soon it will be something else. So it always makes sense to pin this to a specific version, at least to a major. But if you maybe have a dependency on a specific version, you could also enter that specific version. But certainly never use latest, because that is kind of out of control. When a new release is created and latest changes version, then your application might break. And then we have already seen that we have a quite big image. The reason for that is that it's an Ubuntu-based base image. We can switch that to Alpine Linux, which makes it a lot smaller. It has a lot less stuff installed. So that means also if someone tries to attack our application, there's a lot less attack surface, a lot less things that can go wrong. So that is also a very good best practice to move to a smaller base image if we can do that. So let's take a look at how that works. So we go back in here, and instead of having latest, we go to 9.0 Alpine. Pine. So this is now fixing it to the to .NET 9 and also to the Alpine base image. Let's do our Docker build again. Bump the version and start that one. You would have seen similar output here, but I've ran it before, so that's why I can use the cache. And if we now use the same command, we can see here that it still works. So the new version is still doing the same thing. No surprise here. And the improvement is that we already lost 140 megabytes roughly. So it already is quite a bit smaller. And that's quite slow. I hope this is coming up soon, but typically also because it has less packages, less stuff is included, we can also see less vulnerabilities for the Alpine images compared to the Ubuntu images. Maybe we can also see it here. No, not really. Okay, let's wait for that one to finish and then get back here. But the main point is that we now fix the version. We have a smaller base image, so there is less to attack on our side. The next interesting question is what goes into our build context. So the idea is that when we hand over things to Docker to build our image, we want to make sure that as few or as little local artifacts as possible enter the build context. For that, we have a file called docker-ignore that works very similar to git-ignore. And I always let VS Code generate it because it's good at that, but we'll take a look at what it looks like. And the basic idea is that you exclude as many files as possible. You only have the things that you absolutely need in your build context. And that means that only when something changes that is relevant, we need to create a new version. And also it's just faster and smaller. You sometimes also might have some secret stuff, passwords, hashes, whatever in a local file that you definitely want to make sure that it never makes it into that image. And that would then also be candidates for putting it into that docker-ignore file. So let's take a look at that again. And we have the docker-ignore file here. So you can see typical things that you might want to exclude, like the bin folder, the object folder, and then things by convention that might be living in your local folder, or also subfolders for Visual Studio Code, which is just for the IDE and is not needed when we run this in production. So that's the kind of thing you want to exclude here. To give you an idea of the consequence, if I were to run a Docker build again, you can see that everything is cached. But if I remove the Docker file here, so it's no longer ignored, and let's say I do an expose 8000 as well, that means that now the Docker file is changed, and because we removed it, and I should save this, and we removed it from the docker-ignore, when we run a Docker build again, and I'll just stop it here to show you, you can see previously it had everything cached because it recognizes that no new files have been entered. But now it needs to work on that again, because as soon as we copy something in, I have changed the Docker file, I have removed it from the docker-ignore, so now suddenly the Docker file is also added to the build context, and that means that Docker recognizes, okay, I need to rebuild that image, and I can't use the cache anymore. If I enable it here again in the docker-ignore, and I run the Docker build again, you can see it completely can use the cache again. So that's also another argument where you want to use the docker-ignore file wisely to make sure that you have as few builds as possible. Now this is really not looking good. Let me stop that and try with the other one. I hope that one will work better. Yeah, so this is the build context that we need to configure and make sure that not a lot is entering that context. Next interesting question is how we actually want to build the image. So what we want to make sure is that our different layers, and each of those layers correspond to one of the commands that we have in our Docker file, only changes when, didn't want to do that yet, only changes when we make a change to the relevant parts. So the first step typically is that you just copy in your CS project definition and execute the restore. So that means when we do a code change later, we don't have to rebuild that layer, because that one only has to be rebuilt when the CS project changes. We also want to make sure that we have a fast and optimized publish. So I'll use a couple of parameters with the no restore, publish trimmed, publish ready to run, and publish single file to make sure that we really have an optimized file for later running in production. And the most interesting part actually is the last one, which is the idea to have multi-stage images. So the .NET images I mentioned before, we have the SDK image, but we also have a runtime image. We have an ASP.NET image that only contain the runtimes. And we have one that is called runtime dependencies with only the necessary dependencies if you run with a self-contained executable, so that we don't need to have the full environment, basically. And that's what we're going to do. So the idea is to have one stage that does our build, one stage that actually has the runtime. And because of that, during the runtime, we no longer have the full SDK. We no longer have all the dependencies that we might need during development, but we really only have what we need for running the application. How does that look like? Go back in here on the Docker file, and I'll copy that in again because that's a bit of a bigger change. So now you can see our from is still the same SDK 9.0 Alpine, but it now has a name, in that case as build. So we're telling it that this is actually, let's switch back, that this is actually the build stage. We do the same as before, but now we only copy in the CS project. We do a .NET restore with the publish ready to run. Enable the word wrap so you can read everything. Then we copy in the actual source code. We do a .NET publish with the parameters that I mentioned, so we get an optimized self-contained single file. And then the interesting part happens where we again do another from. So we're basically resetting, so to speak, and we go for only the runtime dependencies image. Still 9.0 Alpine, we call it final, and then we have the same parameters as before, but we now copy the result of the publish of the build stage into the final or the production stage. So because we have that one called build over here, and we published into the app publish folder, we can do a copy down here from that build stage, from the app publish folder into the app folder that we just created. And because it's now a single self-contained file, we can just run /project. What does that look like? Let's try to run the build again. Again, I've done this before, so this is why it's cached. But you can now see that we have the different stages. So the final stage, the build stage, and you can see the different steps here, second, third, fourth, fifth. You can also see that it actually is able to run the early steps from the final stage already without the build stage. You can see here, for example, creating the work directory, the /app directory, that can happen before the other one because it doesn't have a dependency. But then we have a dependency here on the build folder, and then it knows that it on the build stage, then it knows that it has to run through all the build steps, and then it can use the result and put it into the final image. So let's run that one as well. And go back here just to show you, yes, it still works. So the application is still fine. But the interesting part now is if we do a size comparison, you can see now that we went from 703 megabytes to 135. And the main reason for that is that we no longer have the full SDK, but we only have the runtime that we need. And of course, our application is also a bit smaller, but that's the big optimization that we ran here. Let's take a look. No, Docker Scout doesn't want to work. Let me try the very small image. Maybe that at least works. And see where we can go from here. That actually should be quite fast. Yeah, okay. So for whatever reason, the bigger ones didn't want to work. What you now can see here, okay, I have 20 packages. It doesn't recognize anything that's vulnerable. For the other ones, it would have been like 650 packages, and it would have found some vulnerabilities. At least when I ran this morning in a dry run, I got a couple of vulnerabilities. So you typically would get the output here that shows you the vulnerabilities, gives you a link to the CVE, so you can take a look whether that is something that actually impacts you or not, and what the mitigation steps are, etc. So this gives you a nice way to check your images for vulnerabilities and make sure that you only deploy things to production that are as safe as you can get. So this is the idea of optimizing the build, mainly through the multi-stage and also through a couple of parameters. Another interesting thing when you run containers is that you have an idea of whether the container is still running. And the idea in Docker is, or in Docker files, is that you can display a health status. That can be done directly in the Docker file, as we will see in a second, for simple containers. If you run this in more complex scenarios like Kubernetes or other orchestrators, then they can also use that health status to figure out when a container needs to be replaced. So while it's healthy, it just leaves it running. But when the health status goes bad, then maybe for longer than 90 seconds, it just throws away the container and puts up another one. But then that is often done with a mechanism that is specific for the orchestrator. But I show you how it would work in an easy Docker file. Yeah. So for that, let's go back in here. What I did in the application is that I added the map health checks. So I know that I have this health check endpoint that I can use. And to do that, I need to go back into my Docker file and do something like this, where we basically add curl, and then we run that against the health endpoint. If that works, we are fine. If not, then we exit with an error, and then we recognize that we're not healthy. Just to also give you an idea, if I would, for example, find a vulnerability in OpenSSL, which was the case in a previous demo, then I could do something like this to fix that vulnerability. So I basically have the typical mechanisms that I have in Linux to do an upgrade, to fix stuff, to uninstall stuff, whatever is needed to make that vulnerability go away. So that would be the way here. So let's save that one again and build it. And now, because this basically is a non-deterministic command, it had to redo some of the steps, although it would have been cached. But I can now run it, version 004. And if I now add an additional terminal, and I'm quick enough, yes, indeed. Now you can see here that we are running that image, and it has a status of up and running for 6 seconds, but it has a health state of starting. Reason for that is that by default, Docker lets the container have 30 seconds until it first probes for the starting, for the health. Until then, it says just health is starting. If I do this again, and now we are past the 30 seconds, you now can see that it has turned healthy because it has called our health endpoint, and that one, of course, returned true in this easy scenario. So that's the reason why it now says that the container is healthy. So that gives me that kind of control. Now we're almost at the end. Now, another thing I want to show you is how the configuration mechanisms work. That is not extremely interesting because it works exactly the same as it would outside of a container. So you just set environment variables, for example, the ASP.NET Core environment, and that gives you the control over how your container works. To show you, I have in here the Open API or Scalar reference in here. In development mode, So right now I'm not running in development mode, which means that if I go to scalar here, it says that it's not available. But if I stop my container, start it again, but this time in development mode. So let's put in the ASP.NET Core environment, same image. You can already see in the last one, it said hosting environment production. Now it says hosting environment development because we have added that environment variable. And that also means that it now has scalar activated here. So I could interact with that one. Yeah, so that's the configuration, typical things that you would do outside of a container as well. One additional thing that's interesting is which user you want to use. Definitely something that's non-root, because if someone would attack your application, would be able to find whatever kind of vulnerability, and you would be running this as root. That would, of course, mean that the user or the attacker would have root permissions as well. And the easiest way for that is to create a new user without a password, give it access, and use that one to run it. Or by now, the .NET standard images come with a predefined user that we can also use. And I'll show you in a second how that works. For those of you that are using Windows containers maybe, or have an interest in that, just a side note, you can also use group managed service accounts to get authentication against your Active Directory up and running. So you can also do something similar on Windows as well. But let's take a look how it works. Go back in here. And first I want to show you, actually, let's try that here. That's easier. We have our container up and running. And if I get a terminal into that container and check who I am, then I'm root. And if I check who is running our little application, then you can also see that it is root as well. So basically, if we do nothing, then we still have root as a user, and that's typically not what we want until we have a very specific reason for that. As I mentioned, the solution for that is to just create a user and then use that. So let's do that after the APK, because that would only work with root. So we're adding here a user without a password and giving it permission to the folder where our application lives. And then we instruct Docker, in that case, to use the non-root user that we just created. So if we, again, run that one and run a Docker build, not the Docker run, but the Docker build, here we go. You can now see that it had some additional steps, which created the additional user. And now let's do the Docker run. So the application should hopefully still be working. Yes, it does. But now if we, again, get a terminal into that container, you can see that I'm already the non-root user. And if we check who is running the application, our little project, then you can see this is also the non-root that we just created. So now if someone would attack, if someone would be able to steal that session, it would only be a non-privileged user. As I mentioned, the alternative to creating your own user, if you don't need that level of control, then you can also, since .NET 8, I think, do something like this, where the standard image has a default user known via that variable. So if we build that one again, run again, and check, and then you can see that it's now a user called app, and also the application is running in the context of that user called app. Okay, so that way we have solved the issue of running as root. The last one, and that's basically the most way to go, or the furthest way to go, is to use something that's called a chiseled image, or sometimes also called distroless images, which are further optimized, and they really have nothing that is not strictly needed to run your application. It also means that it doesn't have a shell. So if we use that one and go back here, I don't use the Alpine image, but let me see what it's called. It's called Noble because it's only available on Ubuntu or on the Azure Linux subscription by Microsoft. And for that, I also need to change the build image. But what we now get, run the build again. And of course, I need to remove this because I am no longer root. That is also a part of the chiseled images, that it's by default not running as root, which also means that our APK add no longer worked. Let's try again. That has worked. So let's start that one. Let's see. It's still working. But now if I would go back into Docker Desktop and try to get a shell into that one, you can see that it says unable to load, exec process is not started. And the reason for that is that the base image doesn't even have a shell. So there's nothing I can execute. Again, if an attacker would be able to break out of that one, then there's not a lot they can do. They don't even have a shell. There's no way to run anything. The consequence, of course, is that, as we've seen, I also can't do a run now over here. So if I need to install anything, if I need to run anything, that just doesn't work here because I don't have anything to execute. So if I'm fine with the base image, if I can use that, then this is a pretty safe way to go ahead with it. It also, as I mentioned, by default runs in a non-root environment. But if I need to do some runs during the creation of the Docker file, then I'm stuck here and I can't use that one. So then the actually very last thing I wanted to mention is that there's also a simpler way, a .NET integrated way, so to speak, of creating container images where you don't even need a Docker file. So if you felt like that was a really boring, 45 minutes, or you really don't want to learn that, then you also have the opportunity to directly use a .NET command. It creates local images, and you don't even need Docker if you use it to create something with a remote repo. I have to say that I only have the experience through some testing and following the announcements because I'm kind of comfortable with the Docker file, so I don't necessarily need a solution for that or need an easier way. But to give you the full picture, that is also possible. So what you could do is you could create or run a .NET publish, as you can see here, with a publish profile of default container, and that would mean that it creates a container image for you directly, without any Docker, without a Docker file. The file is still here, but that's not used, but instead directly with a .NET publish. So let's give that a couple of seconds because it takes a bit, and then it should give us another new image. And because my project is called project, it will also call the image project. Let's see. Maybe to briefly check, our last image had 133 megabytes. So that's basically as small as we could get with the steps that I've shown you. Let's see what that one generates. It typically takes around 45 seconds. So let's see. Yeah, here we go. Now we can compare. We have 240 megabytes, so a bit bigger. You can also see here in those layers the commands that are used. So it also does an apt-get update. It does some kind of user management. You can see here what is happening inside that one, but you can't specify your own Docker file to have basically full control over it. If we run it, that should still be the same. Now we are not using our image, but the project, and it creates a latest. And because we now no longer have the ASP.NET Core URLs command, it uses the default port, which is 8080 in that case. So now we still should have the application up and running. Yes, that still works. So if you want a directly .NET integrated way to work with it, if you don't want the hassle of the Docker files, you don't need the additional control that you get, then this is also an option to create your images and then your containers. And that's basically it that I have prepared for today. Thanks a lot for listening. I hope I gave you some ideas of what you can do with containers, how you can maybe use them. And if you have any questions, let me know. And also, if you at some point want to discuss, reach out to me. More than happy to do so.
Cool. Thank you very much. I think we've got a couple of questions in the chat. I can relay them back. So one of them is, how would you run dependencies such as Postgres, Azurite, etc. as part of a dev container locally?
That's a very good question. What you can also do is that you create multiple containers. So maybe that could even be a follow-up session if you want to have me one more time. But the basic idea is that you then can have multiple containers. So you would, for example, Postgres, or there is, I'm not sure if there's a predefined example, but there is a predefined example with a Microsoft SQL, where you would spin up SQL in a container, you would spin up your application in a container, or you could maybe even have a backend and a front end in dedicated containers. And then those containers together would be run with a single command. Everything would be started. They could talk to each other. They could connect. And that way you could do development across or with an additional backend like Postgres or something like that.
Cool. Thanks. The other question was, do you see many users of Windows containers these days, or have they fallen out of favor? I'm yet to encounter any in the wild in 2 years of using containers.
Yeah, I think that's a very good question. And I would say, no, they haven't fallen out of favor. They've never been in favor, I would say. So yeah, I'm in a situation where I'm working with Business Central, the Microsoft Dynamics 365 ERP system. And that one just runs on Windows. So we were forced to use Windows containers. And if you're forced, then you can make it work, to be honest. So it's not as bad as it maybe sometimes sound. But I have to say the whole community, tooling support, stability, speed, basically everything is better in Linux containers, to be honest. So when you have the opportunity, I would really say go for a Linux container. If you have to, because whatever workload you're running only runs on Windows, then it's certainly also not impossible. I'll give you an idea, the company I work for runs 100 Windows containers continuously or in parallel every day, because our developers need Windows backends. So when our developers come in and need a development environment, they have some kind of tooling, but that spins up Windows containers. And then during the day, 100 Windows containers are up and running. And that works actually quite well. So not impossible, but if you have the choice, go for Linux containers. You're not as alone as you are in the Windows container world.
Okay, cool. The next one is there a way to create your own chisel images with like packages for your own app? So if it requires like something inside the like apt-get or whatever.
Yeah, you would basically have the same process. You would start with the full image, and then you would chisel away the stuff that you don't need. I have to say that I've never done that before, but I would say it should certainly be possible, but I can't claim to have practical experience with it.
Okay. Do you prefer using Ubuntu, Chiseled, or Alpine? Which is the better? Are they the same?
Yeah, so if I have a choice, if I can run with the chiseled image, I would go with that one, because as I mentioned, it doesn't have a shell. That means that I can easily avoid that attack vector. If I have to have a shell because I need to run something during the Docker image generation in my Docker file, then I would definitely go with the Alpine image because they are just smaller and leaner than the Ubuntu images.
Okay. Does that have any problems for like debugging things on like Azure Container Apps or AWS ECS and things like that as well?
Yeah, absolutely. So what you can do is in Azure, there are tools to debug those containers. Locally, you can use Docker debug. And what it basically does is it creates an additional container that has a shell and then connects to the other one. So you can still see the file system, you can still see running processes, but you're not actually in the same container. So if you really need to run in the same container for debugging, then you're out of luck in that situation. So you need some additional tools to get kind of close to it, but you're not getting the same experience.
Yeah. What do we got next? Has anybody had any success with local stack for development? AWS local stack.
Tried, heard and read about it, but haven't tried. So can't say anything on that.
Okay. What's this one? From close to the start of the presentation, when in VS Code containers, how can we tell whether we're in local inside the container? It looks like it's just the same as local. I'm guessing that's a shell, maybe.
Yeah, that's a very good question, and I forgot to show you that. So let me share briefly once more, and I think I need this window. Put this out of the way. Share. Now you should see my dev environment again.
Yep.
On the bottom left here, you can see dev container C#.NET. So in the bottom left, you would see whether you're running locally or not. Just as a comparison, if I open up a local VS Code, then you can see here in the bottom left just the logo. But if I'm running in a dev container, then I get the little note here that tells me that I'm now in the dev container.
Okay, that's good. I think I've got one more question about Aspire. So how do you feel about Aspire for building container-based apps?
I feel that it sounds very, very interesting, and I definitely have to take a look, but I unfortunately didn't have the time. That's one of the things I hope if I have some time over the holidays now that I can take a look, because I think it's a good combination. It answers some of the similar questions, but it's also not a complete replacement as far as I understand so far. So yes, similar questions, but not exactly the same. But I have to dig deeper to give you a real answer.
Okay, cool. I think that's it. Has anybody else got any questions? I'll give you a couple of seconds to post any if anybody's got anything else. But yeah, thanks again. Much appreciated.
Thanks from my side as well. Thanks for the questions. Always good if I'm not just speaking with the moderator, but also get some questions. So very much appreciated. And again, if you want to dig into the multi-container scenarios, let me know. I'm more than happy to join. As I mentioned, we have a UK sister company, so maybe I'm even there and can visit in person. Would love to do that.
Yeah, that'd be pretty cool. Yeah, keep in touch, and we're happy to kind of host again or kind of in person. That'd be great.
Perfect. Thanks a lot.
Thanks again, everybody. Thanks for the turnout.